Today we will discuss the numerical problem on compaction of soil. We have an example from a site, and the following data refers to a compaction test as Indian standard IS light compaction. Specific gravity of soil grain is equal to 2.7. Unit weight of water gamma W is equal to 9.8 kilonewton per meter cube. It is a constant. We usually take it 1 gram per cc or 9.8 kilonewton per meter cube. Relative compaction, it is given in the question, that is 95%. And volume of mold in case of IS light compaction, we all know it is 1000 cc. IS light compaction test was done in the laboratory, and the result is tabulated in this table. The water content in percent and weight of wet sample in kilogram is given here. For example, for water content at 8%, weight of the wet sample is 1.80 kg. Similarly, 5 other data is given in this table. Based on that table, we have to plot the compaction curve and obtain the maximum dry unit weight and the optimum moisture content. We have to plot the 80% and 100% saturation line. If it is proposed to secure a relative compaction of 95% in the field, what is the range of water content that can be allowed? Would the 20% air void curve be the same as the 80% saturation curve? So from question it is clear that we have to plot the compaction curve, then we have to find the maximum dry density and optimum moisture content. To plot the compaction curve, first of all we have to do some calculations. Here we can see in the table water content and weight of wet sample is given. From this we can calculate the bulk unit weight of the soil using this formula, gamma is equal to weight by volume of the mold. See here, we can easily calculate weight of the wet sample is given and volume of the mold is known as 1000 cc. So we can easily calculate for all the water content percentage. Bulk unit weight is equal to here this weight of wet sample divided by weight volume of the mold, and to convert it into kilonewton per meter cube, we have just multiplied 1000 into 9.8. it will give the value in kilonewton per meter cube. After calculating the bulk unit weight of the soil, our next task is to calculate the dry unit weight of the soil using this formula, gamma D, that is dry unit weight, is equal to moist unit weight or total unit weight divided by 1 plus W, water content, that is water content. So dry unit weight can be easily calculated by this bulk unit weight divided by 1 plus this 8.5. since it is water content is in percent, so 8.5 divided by 100. So in this way we can calculate for all the water content dry unit weight of the soil. In the question we have it is asked that we have to plot for 80% saturation and 100% saturation. So we have to calculate the unit weight for 80% saturation and unit weight for 100% saturation. Here we can see the formula, gamma D is equal to G by 1 plus E gamma W, but WGS is equal to AC. From this formula we can put E is equal to WG by S in place of E in this formula. The formula becomes like this as shown here. To calculate the 80 unit weight for 80% saturation, just put the value of S as 0.8 in this formula. We will get the unit weight at 80% saturation. Similarly, for 100% saturation, we have to just put S is equal to 1 in the formula, and in other column unit weight for 20% air voids, we can put the formula, the last formula gamma D is equal to that. For the last column of the table, just put Na is equal to 0.2 in the formula of gamma D. Now from this data we have to plot the compaction curve, that is curve between the dry unit weight and the water content of the soil. So now we will do the simple plotting process in the Excel. First insert, then we will take the scattered form and we will select the template of the graph, then select data. Now press the add button. We can write the series name, just like compaction curve we can write, or whatever we can write. And for X series we will select water content data, and for Y series we will select the dry unit weight data and press OK. Then press OK. This will give the compaction curve like this. As we have already explained, initially the curve increases up to a limit, that is at maximum dry density. After that, if the water content is increased, the curve decreases. This point is called maximum dry density, and corresponding water content is called optimum moisture content. In this way we can calculate the maximum dry density. It is approximately equal to 17.4 plus, and the optimum moisture content is approximately equal to 15. So as per the question, we have to calculate the maximum dry density and optimum moisture content. From this curve we can easily calculate the maximum dry density and optimum moisture content. We can write, or we can edit the axis, like here we can write gamma D, and we can write here water content. So for better presentation we can label the axis of the graph. Now we have another data to plot, that is dry unit weight for 80% saturation and 100% saturation. In the same way we will plot the graph of 80% saturation and 100% saturation. In both the cases the water content will be on the x-axis and the unit weight will be on the y-axis. So we just repeat the same procedure of graph formation as we discussed for the compaction curve. So just you can see how these graphs are formed. Here the graph looks little different. Just we have to format or set the minimum and maximum of the axis. So we will format the axis and adjust the minimum and maximum. The graph will be okay. So do it. With little adjustment of the maximum minimum limit of the axis, especially for the y-axis, that is gamma D axis, the graph looks like this. And now we can see the 80% saturation line. To plot the 100% saturation line, we will repeat the same process: add, select data, name of the series, all these things. Just repeat the same what we have done for plotting the graph. This is not based on any concept. Just we have to keep in mind that in the x-axis the value of water content is plotted, and the y-axis the unit weight for 80% or 100% saturation is plotted. So this is the plot for 100% saturation or this plot is also known as zero air void density graph or density plot. It is very important, already explained in our previous lecture what is the meaning of 0% air void density. So these plots are, now it is clear. Now we have to plot the graph of unit weight at 20% air voids, that is last column, and between the water content of the soil. So uh, in the same way, just plot the graph as previously described. Take the series name, select the x-axis as water content and select y-axis as dry unit weight for 20% air void density and press OK. The graph will appear as usual. So see here, OK, just OK. Now you can see the graph. So from this graph it is clear that it is not equal to the 80% saturation line. The last question was, would the 20% air void curve be the same as the 80% saturation curve? No, it will not be equal. So it's very clear that 80% saturation line is not equal to the 20% air void curve. So we have plotted all the curves as required in the question. Compaction curve, 80% saturation curve, 100% saturation curve, and 20% air void density curve. Now come to the third question. Here it is proposed to secure a relative compaction of 95% in the field. What is the range of water content that can be allowed? For this we have to calculate the density in the field. As we know, relative compaction is equal to gamma d in the field divided by maximum dry unit weight. Here field density or field dry density gamma d field in kilonewton is equal to, since relative compaction is given and we have just calculated the value of maximum dry density, so density in the field is equal to just multiplied by relative compaction with the maximum dry density. Since it is in percent, so multiplied by 100, we will get the value of field density. So to secure a relative compaction of 90% in the field, the range of water is corresponding to 16.58 field density. The range of water will be approximately 10% to 17%. So in the field we can manage, or we can arrange, or we can mix the water as 17% to 10% to 17% to acquire the relative compaction of 95%. So this is the third question. I hope it is clear to. Here I have shown the final result of the problem. I have drawn compaction curve, labeled it properly. From the compaction curve it is clear that the maximum dry density is 17.45 kilonewton per meter cube, we can see here, and the optimum moisture content is 15.17%. The 80% saturation line is shown here, the 100% saturation line is shown here. So all these details are discussed here. I hope it is clear to you. Thanks for watching our video. I will regularly post soil mechanics related topics in our YouTube channel. So keep on watching, keep on sharing. If you are new in this channel, then subscribe our channel. Thank you once again.